In this video, we're going to learn how to balance an acidic redox equation. First of all, we can see that it's acidic because we have sulfuric acid right here. The first step is finding the oxidation state. For that, there is multiple rules. First of all, the oxidation state of an element in its natural form, such as O2 or N2, or here we have our sulfur in its solid form. All of these will have an oxidation state of 0. The second rule is that any atom from the first group will have an oxidation state of 1, and any atom of the second group will have an oxidation state of 2. The third rule is that oxygen basically always has an oxidation state of -2, except in the case where it's O2, because here it's 0, and in some case where it's a peroxide, for example in H2O2, it will have an oxidation state of -1. But for the most part, we will remember that oxygen is -2. The same thing goes for hydrogen. It's almost always +1, except in its H2, so dihydrogen form, where it's 0, because of the first rule we saw over here. The last set of rules applies to molecule and ions. So when you have a molecule, for example here KMnO4, the sum of the oxidation states will always be equal 0. And if you have an ion, let's say Cr2O7 -2, the sum of the oxidation state will be equal -2 because of the charge here. Knowing this, we can now find the oxidation state of every atom on the list here. So K is equal +1 because it's in the first group. Manganese, we don't have a rule that tells us directly what is it equal to, but we know that oxygen is -2, and here, very important, we have 4 oxygen, so that will be -2 times 4, which is equal -8. So we know that we have +1 and -8, and this needs to be equal 0. So that's -7 equals 0, so we have to add 7 here. So this 7 right here will be the oxidation state of manganese. So now we have H2S. H is +1, and since we have 2 of them, it will be +1 times 2, which is equal to. So the sulfur atom will have an oxidation state of -2, since the whole molecule needs to have an oxidation state of 0. Now for the sulfuric acid, we have the hydrogen, and we have 2 of them, so that will be -1 times 2, which is equal -2. The sulfur we cannot find directly here, sadly, but the oxygen, we know that it's -2 times 4, so -8. And so the sulfur will needs to be -2 plus 8 equals 0. That's 6 equals 0, so the sulfur, we know it's -6. Now for the manganese sulfate, we know that it has a sulfate group which charge is -2. There is a set of groups like this that you need to know the oxidation state. Sulfate is one of them. So since it's -2, for the whole molecule to be equal 0, the manganese needs to be equals 2. Here we saw that an atom in its natural form will be equal 0. Now, for the potassium sulfate, I just realized that I wrote the molecules wrong. It's K2SO4. The SO4 we just saw right before that it's equal -2, so the K is equals 2 times 1 because we have 2 potassium atoms. And for H2O, so water, we know that we have 2 times 1 for 2 hydrogen, 1 time -2 for oxygen. So now we'll observe which compound oxidation state changed. So we can see that at the beginning of the reaction, the manganese oxidation state is +7, and at the end of the reaction is +2. So we know it's an atom that will have a role in the redox reaction. Secondly, we can see that at the beginning of the reaction, sulfur has -2 oxidation state, and at the end it has a 0 oxidation state. So we know that's the other atom that will have a role in the redox equation. Now we have to define what's reduction and what's an oxidation. So a reduction is when the oxidation state of an atom becomes smaller. So here it will be for manganese, since it goes from +7 to 2. So we can write the reduction equation. Now it's important that we don't write KMnO4 becoming MnSO4, because those are not directly involved in the reduction equation. But it's important not to forget the charge of the group. So we removed the potassium, so we need to add minus here, and there we removed the SO4, so we need to add 2 plus, since the SO4 was -2. Since we're lacking some oxygen on the other side, we will add water. When you are lacking oxygen, you always need to add water to the other side. So since we need 4 oxygens, we will add 4 water. But now we are lacking hydrogen. Since we are on in an acidic environment, we will balance the other side not with H2 minus, that is for a basic environment, but with H plus. And we need 8 of those, so we write 8H plus. So now we are just lacking one last thing in this reduction equation, which is to add electrons. So we went from +7 to 2, but we need the total of oxidation states remaining the same on each side. So in order to do that, we will add electrons, because they have a charge of -1, and since we went from 7 to 2, we did -5, so we need 5 electrons. Now for the oxidation equation, we can see that the H2S, in the H2S, the sulfur went from -2 to 0 in the sulfur in its solid form. So we will write this, but here we are lacking some hydrogen on the other side, so we will just add them. Here, for the oxidation state, we went from -2 to 0, so for this side to be equals -2 like the other side, we will need to add +2 electrons. But now we can see that our reduction and our oxidation don't engage the same number of electrons. In order to fix this, we will need to multiply both reaction by some number. The easiest way to find this number so that the number of electrons are the same is just to multiply. Here we have 5, so we multiply this reaction by 5, and here we have 2, so we will multiply this reaction by 2. By doing this, we now have 10 electrons engaged in the reduction and 10 electrons engaged in the oxidation. Now we can simply add the reduction and the oxidation together. So we will take the MnO4, but we have 2 times it, so 2MnO4 plus we have 2 times 8 hydrogen ion, so 16 hydrogen ions, plus 5 times H2S, so 5 H2S, which reacts into 2 times Mn2 plus 4 times 2, so 8 H2O, plus 5 times the sulfur in its solid form, so 5S, plus 2 times 5, so 10 times H plus, and we don't need to write the electrons since we have 10 electrons on this side and 10 electrons on this side, which we will simplify. We can also simplify further because we see that we have 16 H plus here and 10 H plus here, so we can delete those one and subtract 10 H plus here, so that will be 6 H plus. So this equation right here is our ionic equation. To find the molecular equation, we simply need to take our equation that we had in the start, which is here, and use the atoms that we left out at the beginning. So for example, K, SO4, and the same thing here, K and SO4, and add those into our equation. So here we have 2 MnO4, but we will add a K, so it will be 2 KMnO4 plus 6H plus. What could we add to the H plus? Well, this is SO4, so we will have 3 H2SO4. Why 3? Because we have a 6 here, and 3 times 2 equals 6. Plus H2S, this reacts into 2Mn2 plus. What could we add to that? Well, here we see that we have MnSO4, so it will be 2MnSO4 plus 8H2O, we don't need to write anything to this, plus 5S in its solid form. We just have one last a little bit tricky thing to do. We see that on this side we have 2 potassium atoms, and on this side we don't have any. So we see that on this side here, the potassium atoms are in K2SO4, so we will just add K2SO4, and now we have the same number of potassium atoms on either side. So that's it for the video. Let me know what you understood well or not in the comment section, and I could try to help you.